In this video, I'm going to go over using the double angle and half angle formulas. So first, for the double angle ones, I'm going to go ahead and derive these from the previous formulas that we did in 7.2, and then use them in a few problems. And then I'm not going to derive the half angle formulas, but I'll show you what they are and how to use them to find the sine or cosine or tangent of angles that are actually cut in half. Okay, so we're going to start with the double angle formulas. All right, and these are essentially just special cases from our formulas that we used on the last one, where we talked about looking at adding the sum and difference of two angles with sine and cosine. So this is the special case where alpha and beta, or A and B, are actually the same. So what we're going to do is we're going to actually set this also equal to theta and replace the alpha and the beta with theta, and you can see what's going to happen to these formulas. So it'll be the sine of theta plus theta equals the sine of theta times the cosine of theta plus the cosine of theta times the sine of theta. So what happens is we have sine of theta plus theta, which gives you 2 theta. That hopefully should make sense. We're talking about double angles, so times 2. And if you look, even though the order is different, right, it is multiplication. So because multiplication is commutative, that these are actually the same thing. So we write it as equal to 2 times the sine of theta times the cosine of theta. So this is one of the first double angle identity. Let's do the next one. Same thing. Replace the alpha and the beta with thetas. So I have cosine of theta times the cosine of theta minus sine of theta times the sine of theta. So similar idea to what we did in the previous one. This becomes 2 theta. But if you notice, we have cosine times cosine, which is going to be cosine squared theta. And then minus sine times sine, which is sine squared theta. All right, so that is our second one. Now, because of one of our Pythagorean identities from the very first lesson in this unit, we can actually take this cosine of 2 theta and rewrite it to have 2 extra ones. Okay, so we're going to use this Pythagorean identity from the very first lesson on this unit. Sine squared plus cosine squared equals 1. So if we manipulate that, I don't care the order which you do this. All right, I'm going to first manipulate the cosine squared. All right, so if I rewrite cosine squared, that's the same as 1 minus sine squared. So this becomes 1 minus sine squared theta minus sine squared theta. If we take the parentheses off, we have 2 of the opposite of sine squared theta, so that's equal to 1 minus 2 times sine squared theta. All right, do the same thing, but this time replace the sine squared using our Pythagorean identity. So copying on the cosine squared. And it's going to be minus, and sine squared is the same as 1 minus cosine squared theta. If you distribute, you'll have a minus 1, but subtracting a negative cosine squared theta is actually another positive. So we get 2 of the positive cosine squared thetas minus 1. So again, I don't need you to know the derivation that we just did for these different formulas. I will be asking you to do a formula quiz where you have to memorize these formulas. All right, last one for tangent. Again, we're going to replace theta for A and B, or alpha and beta. So tangent of theta plus theta is equal to tangent of theta plus tangent of theta over 1 minus tangent theta times tangent theta. So again, we have our double angle, right? 2 theta equals, that's going to be tangent theta plus tangent theta, which is 2 times the tangent of theta, over 1 minus tangent times tangent, which is tangent squared theta. All right? So again, not worried about the derivation, just need to make sure you know all of these formulas. And now we're going to do a couple examples to help us figure it out. So This first one says, given that the sine of alpha is 5/8 with, this is the angle or alpha, is in quadrant 1. So quadrant 1. All right, we've got quadrant 1. All right, there's our alpha. Find the cosine of 2 theta, or excuse me, 2 alpha. So the cosine of 2 alpha is one where you've got 3 different options. Okay, so remember you've got 3 options here. And when I look at what I'm given the sine of my angle. So I only want to choose the option that only has sine, which is the second option here. So that's equal to 1 minus 2 times the sine squared of alpha. All right, so I'm going to plug that in. 1 minus 2 times the sine of alpha is 5/8, and we're squaring that. That's 1 minus 2 times 25 over 64. 1 minus, that's good. That 2 over 64 will reduce to 32 in the bottom, so 25 30 seconds. And if you were to change the number 1 to have a common denominator of 32, you get 32 30 seconds minus 25 30 seconds, which will give us 7 30 seconds. And that's it for that first one. Okay, let's do the next one where we're going to use one of our, I guess really not one of our things. Oh, sorry about that. Where we're going to use, come back. There we go. We're back. Where we're going to use our understanding of algebra to help us make this a true statement. So we know it's true. Let's verify it. What I notice on the left side, it's a little bit more complicated. I've got 2 trig ratios raised to the 4th power, but it's connected by subtraction. So this is actually, when I look at that on the left, I'm thinking this is dots, the difference of 2 squares. So I have cosine squared theta minus sine squared theta times cosine squared theta plus sine squared theta. And that makes me very happy now, because if you look back at the one we just used before, right, sine squared theta plus cosine squared theta is one of our Pythagorean identities, which is the same as 1. All right, and even though the order is a little bit shifted because it's addition, which is also commutative, this right here, is going to be equal to just, I guess I should draw it all the way over, equal to 1. All right, so now I just get to bring down cosine squared theta minus sine squared theta, and this is one of the new identities from today, where the cosine of 2 theta equals cosine squared theta minus sine squared theta. So if you do the very last step, right, we replace this with the cosine of 2 theta, right, which equals what we wanted to. All right, so that was just using some old identities and some new ones in the same problem. Okay.